I'll show you. Hmm? Oh yeah, that's yeah, we got plenty of cookies today. You don't want to click on that. You just close it out. Click on that, you're gonna get feedback and stuff. So
Okay.
oh, there's a presenter.
Okay, he's already in.
And Dave still doing it?
I see.
That's not perfect. Don't worry about it. Wolf Hall, you're still my man?
Yep, I'm still doing it.
Good man.
He's back, huh?
Oh, yeah. You know, you flaky people.
Just feels like we feel harsh. Fearing guilt.
Yeah, exactly.
It's all tight with
Jewish mothers, they happen to walk on it a lot.
So Anthony Johnson's in front of it. Then you just get oh, this pretty much is good.
Wow, we have to be coming. We got all hell human beings.
Yeah, so shit.
Hey Bruce, is it or which one is it?
The speakers and topics.
Speakers?
Yeah, that's good.
So you tried and you made sure.
Doesn't go well.
You said very well. The ones that would be so.
Yeah.
I know.
Where's me? I know, where's this thing?
No, it's a nice day.
It's the first one of the fall.
So Dawn, can we get a count of how many people are online?
Well, we see all the time, yeah. It's always here, yeah.
Trying to figure out.
Right now we have three. Well, one. Well, our presenter and Randy Rainville.
So that's not even much online.
Usually get like 7 or 8 online.
Right, thanks.
Yes.
I would have thought more would come back.
That's the first one. We got 180 members or something like that. You know, we got one online.
Now, the last meeting, we had like 10 of the bubble on, about 20 people.
Now BVAA, what do they got?
Oh.
So what are they doing different for?
Oh, bigger group. And they've been around. It's been around a long time. They have legacy for a gazillion years.
John?
Or something quality wise they're offering their members.
I'm the number two. Yeah.
You go
They have a pretty good turnout, but percentage wise, if we get like 30 people online in here, it's about the same percentage.
Percentage-wise,
When you look at their attendees versus their 260 or so members,
there.
70. It's about the same. They have a little bit more.
Yeah.
But they have
Quality thing that you see from them versus us.
really,
As a member there, you're not.
one thing they do,
no.
you know what they do different? They give everybody a name tag. Everybody gets a name tag. They have a guy who's their new member coordinator, the membership coordinator. He gives everybody a name tag when they come in.
As soon as you come in, you get.
They have them all pre-printed on the table, and they come in, you get your name tag.
It's like you're going to a professional meeting, right?
Yeah,
Well, that's
yeah,
the other thing too.
Yeah.
If you look at how many like executive members we have, what do we have, like 7?
yeah. They have like
20.
20.
Yeah.
They have a person who's a greeter. They have a person
Yeah.
who just does astrophotography.
They have tremendous better involvement. They are tremendous member
So
involvement.
the point is, even though the number of people attending the meetings may be less, the dynamics of the organization. So it's just.
Yeah, they have tremendous member involvement in whole classes. We have like, you know, this makes
Yeah,
3 or
yeah.
4 if you want.
Really?
Yeah.
They don't have majority, but they promise having here. They have 3 or 4 people that.
Yeah.
What's that?
Any of them back out last month?
It was too.
I can't still. Bringing up. Don't worry, still overloaded, then do not always work. Okay. When, yeah, having those, pumpkin materials, nourishment, build the program, so. Work the groundhogs going in there and trying to eat them, so. Trying to plug that as well. Let me know when you're ready, I'll come.
Yeah. Yeah, but Detroit now, it's like, oh, Detroit, it's like milkshake.
Yeah, I know.
All milk you see.
That point about I'll see what I think I do tomorrow. I might go to Western, to Cloud, send you a burner. That way you don't have to fret, you got enough going on. You're spending money on this, so you don't have to follow that, but.
Well, yeah.
Eventually, yeah, I should have.
Natural.
Right,
Things like that. And look at the line.
it's like, VHS numbers, there's on the bunch, I'm like, oh, I gotta read this on anymore, I don't have it.
The same.
I remember years ago, I thought, I want to get a television disc player for the movies. Right, that's not like so cool. Right.
So, you know, you can.
About this, I remember, I never made that jump, so thanks, I'll route through your technology. So to make it pretty things, I bought. Well, then I'm just gonna sort on the extra degree.
You could do it. One long gun, Jimmy. Sorry, I'm actually, they want to. That's your virtual. I can put some the bottom.
More than us.
Okay.
Yeah, like this good, there's more powerful, you're hacking anything.
And,
The other thing I do is I usually when we have. I rep you on this, some of this stuff, I should be progress.
Oh, good, yeah.
Shoot, there's a really shot in the ball, very aware, let's see it up. What's right control for all, what's still in.
oh, okay, but yeah, it influences, it's just.
See, I think it's because we don't have Don Brown, especially in reading, so people know about that, we draw them in like. Oh, I drew all this, you don't need it.
But the grant, I give you one for $1.
Wow.
What about? Yeah, well. So, for go for the pounds right here, we'll like, you're on the game, can't help you, you know. No, I got it, so, I dropped a book into the record, I forgot to put out breast. Try to call me for getting to know what you can have on and breast, just. Yeah, and it's from the man, they have a good stuff, yeah, or not, we have a. Farm. And, you know, and the part of all that comes to using the beautiful machines. One of this John. First, she was from my option.
It worked me on the about. Having everything, it worked.
Well, 2 times in one, it's not over possible all the stuff, and then you go.
Next one, yeah.
It's fine.
Where's that gonna be?
In the Denver, we'll have some. That's like it. Two nice paintings, so, yeah.
I've never seen yours already. Good.
Well, it's a, it's small. Too.
You can actually have a wedding inside it. Along with blowing off.
Yeah. This is the applicant.
And along with.
The same thing. So.
That's.
I know this. They come to you, so not really right their house. So they were forced to deal with this on their own.
Yeah.
No. Right, so we might be home.
We have a Ben Farrow time. I've got many problems.
So, yeah, no, that's.
But the, she got the, what's called, the, 1906, she's in reserve. It looks fantastic.
Yeah. I wish that everybody. Stations, things, you know, being made, it looks like such a.
Absolutely.
So, what was it? Neighbor magnet, and we got a full page spread on the international.
Yeah, that's also.
Then the right.
Well, I came through because I got hired from this.
That, because I copied the report to the, so she sent me the whole magazine.
I built them.
And then she said, hey, if you want me to list your events, I heard new dates that they were going to start. I'm gonna put on my calendar, it's very much.
A long last.
We got one of the solar events, this in October that, listed, so there's gonna be Saturday, January. Courthouse. That's all, we just expecting these mobs.
But so what's the things where it is, nobody needs approval, like,
I don't know about because. Earl and the club who was doing it, heading up with the school so we could have permission to do it, left the club. Then she was the only one who has the password for the club email system. The email actually had the permission, so now the school said, "We'll give us your permission for it," but they can't reach. So it's one thing to think of, but I'm like, well, but I didn't, I want to make sure it's all gonna happen. Well, since it's one of those things, and ones that we're looking for, really some good relationship with the children, but I can't get president. Hey, Sue, we're flying to the third.
How are you do?
Good. Can you hear me okay?
Yeah, I can.
Good. Hi, John.
Hello,
How are the kitties? Where are the kitties at?
everywhere.
Yep.
You'll hear them. Actually, the big orange guy is underneath the table right here.
Oh, yeah.
He likes the reflection of my watch. And so then
Leo used to love that. Sun come in on my watch, Leo would run all around. I just saw a kitty come down steps behind you.
Rob also.
um
Executive.
Crystal, nope, that's
I
Parker.
just came down the steps.
Yeah,
they're
that's Parker, the mean one.
Right now, I'm retired. Tell me what needs to be done. Or so they don't want to give up control. So.
Hi, everybody.
Hello, Randy.
It's like John Stewart. Yeah, yeah, John. Hi, John.
Welcome back from Florida.
We were commenting on your hair is very long now.
Eh, I just got a cut last night. It was even longer before.
Down to his knees before that.
No, not quite like that. So
Gather over
Well-
the summer.
So, long story short, the woman that cuts my hair was seriously ill, and between surgeries and chemo and recoveries, it was about a year until I got my hair cut again. So, I wanted to show my support for her by not going to someone else. And
Thank you.
so that's why. And now she's better and she's refusing to cut it short. So.
So I like to actually get all sign objects.
Take this down.
All right, so
I'll
start. So you can start. What's your concern? It's a fun thing. Yeah. I hope the weather's good. So I'm trying to get the service and then the 15th is back. So we're. So pretty bad here. All right. Okay, it's 7:30, so let's get started. Welcome, everybody, here and online to the first meeting of our 2025-2026 CCAS lecture series and mood series. It is great to see everybody here again. And it's kind of nice that you do have these because we have really been skunked in terms of what we're doing. We're actually batting less than 50% in terms of the weather cooperating with our events. However, we've had some good ones. Just to remind everybody, we have a really active solar observing program at this point. And Roger and Linda Kennedy have really done a fantastic job of lining up a lot of events. We've had 2 in the last 3 weeks, and we're going to have, I think, another one coming up this Saturday. Yes. This Saturday. So anybody that's interested, if for no other reason, show up so that you can take a look through their 100mm dedicated solar system. It is a fantastic view. So in any event, I would also like to sort of say at the outset, I would like to remind all of our members about our scholarship fund. We have done a fantastic job of not only supporting one student, but we've done 2 and now 3. And it's been a smashing success. But every year we need to, get donations to the fund so that we can help Westchester students and Westchester University encourage kids that are going for science, technology, astronomy, and other majors that really could use that. So if any questions or if you want to learn about how to donate to the fund, please talk to me or talk to Bruce and Jerry, who manages it, and we're grateful for any help from anybody. So in any event, I'd like to turn it over briefly. Who's Don?
My next.
You're next.
You can, let me share the screen.
All right. You're gonna control it?
Yeah,
All right. Okay.
let me get this set up.
It has been a challenge with the observing, as Dave had pointed out. I think it's mostly my fault. I pick bad weather days. I look through the year, try to figure which one, and Roger is always a hoop because he's always like, well, 2 months from now, that date's gonna be bad. This one, I'm like, how do you know 2 months out? There's just no way. So, is it working?
Yeah.
Ah,
Okay.
beautiful. Yeah, I searched for a new theme for my PowerPoint, so this is the winter theme with
I like
sky.
that. I like that. I'm gonna borrow it.
Yeah, please do. All right, next slide, please. So planets this month, I went out and got NASA Eyes. I don't know if anyone used NASA Eyes. It's a wonderful tool if you haven't used it. So you can actually see Earth and you can see where the planets are. Randy R is on top of Saturn, I think, right there. Yeah, so he's covering Saturn. So you can see Saturn's going to be right in our night sky, but Mercury's too close to the sun this month. Superior conjunctions on the 13th. Venus rises a few hours before sunrise. Again, you can tell from the chart there or the image why that would be the case. Mars, you have to really look into the western sky, but it's only about 4 seconds in size, so you're not going to see much detail. With that, you're going to have to get it fast because it's going to be sinking. You're going to go through a lot of atmosphere, so not exactly a target I'm after. Okay, right now. Jupiter rises 1 a.m. And it's going to keep moving more and more, as you can tell, as the Earth goes around its orbit, going to be more and more in our evening sky. Saturn's getting easier and easier to view, so it's really one of the objects that's a wonderful one. I just love staring at it forever. And Uranus around 10, it'll rise, and Neptune is around 7:30 in Pisces. Okay. And then I just picked out this. I thought Sky Telescope had this is one of their highlights for the month, and I thought it was pretty cool. So there was number of 3 red wonders in Cygnus. So if you get a chance to get out and look at it, that's the QR code for it if you want to use that. Um, V Cygni, it's really interesting. It's a carbon star, meaning that basically the outer levels of the atmosphere have a lot of carbon soot in it. You can think of it that way. And that actually makes it red. So it's basically a similar effect that when we have soot in the Earth's atmosphere that makes the sun when it sets more red than you would normally see. Same thing happens with stars. Then Campbell star in Abirio is small. It's only 5 seconds. I've seen it once. I haven't really gone after it much, but I love planetary nebula. And this is a really small one. It's actually a special class of star that as the star's dying, it goes through the stage, the Wolf-Rayet stage, where they're incredibly hot. And it's putting out about 179 times the amount of energy as our sun. Third object there is one of the largest stars known. And it's probably on most of our scopes. You have to have a really big scope to be able to discover this. Dave, I don't know if you can go to 16. Can you get 16 with yours? You can. So this gentleman could see it. We'll take a picture of it for us so we can see it. That's no problem. No problem. I give out assignments. So thanks. All right, next, please. I just want to show we have a new outreach poster, which I found has been really good. I've used it at one of our solar events, and it was basically packed with people. They really loved it. Basically, there's answer keys at the bottom, and so it has the 3 sections to it. It's 3 feet by 4 feet, so it's pretty large. And basically, those are covered up. My wife's good at making those little flappies. So she made some flappies on here. It's scientific too. Okay. Some of them are really basic, and then some are like, okay, like 17 there. I think that's on the next slide, Dawn. I think I zoomed in a little bit just to see how, so yeah, there it is. So which picture, left or right, depicts the first quarter moon as seen from with the naked eye? Is it the left or right? Club members?
Right, great.
Right is correct. Good job. How many full moons can stretch from horizon to horizon?
Never counted.
360.
360. It's a half a degree,
Half degree.
180, get 360. Okay. You can see for us, these are easy. But for the general public, a lot of them are scratching their heads, but they enjoyed it anyway. Some are a lot easier, and so it's fun. And they had adults and kids were both enjoying
It
it.
got nice attention at Star Farm
Good.
last Friday night. Yeah.
So I'm gonna try to add some of these things to our outreach, so we could maybe mix things up when we're going to some of the events. I envision having like I've done, I have a table out with this, so people can actually just do, especially as it's getting dark, we're still setting up. Dave's pontificating about the stars. Oh, I mean, talking about the stars. And
Orientation.
oh, that's it. Okay, sorry. Next slide, please. All right, upcoming events. We have the York County Star Party, which actually Dawn has been coordinating. Anything you want to say, Dawn?
I have a slide at the end.
Okay. Then we have Wolf's Hollow County Park coming up here. That's going to be a nice one. We're expecting probably 30 to 60 people attendees at it. Not from our club, but that'd be great.
And those are the registered ones. There may be more.
It could be more. Yeah, this usually does well. So Bruce is going to be actually leading that one. It's actually not. Sorry, I Dave is leading that one.
He's just inflicting more guilt.
He backed out on me, so I didn't have time to correct the thought, but no pressure. No pressure. I can always make it so.
Yeah.
Yeah. All right. We have a club viewing event on the 26th. That's a new moon night. Saturn, of course, will be beautiful for us, and of course, deep sky. Then on October 4th is International Observable Moon Night on this campus. Okay, so we're trying to get the final details worked out with the school, but we'll need probably 5 to 6 scopes for that night. So this is a international event. NASA actually is the one hosting it, but we're going to be we're already listed on their website as having one of these events. So
We're coordinating with the student group.
we're working in hand in hand with the Westchester Astronomy Club. So they're actually the ones who are getting the permits for us for actually doing this. But it's going to be a great event. If you can come, even without a telescope, I'm expecting there to be lots of people there. You can talk about the moon. Bruce has been nice to put together some materials we can give. NASA has provided some really wonderful details on what's visible on the moon that night from that phase of the moon and some of the key features. I'm hoping we can actually assign people by telescope to a certain feature so that we're not all looking at the same crater, that sort of thing. So that's the upcoming events for this month and beginning.
Anyone who hasn't been there, Wolf's Hollow is probably the best place in Chester County to see the night sky.
Yeah,
It's clear and it's a wide horizon. You can see the entire sky.
it
So
is a beautiful
Wolf's
spot.
Hollow is a great place to observe.
Thanks,
It's a
Tom.
bit of a drive from here, but it's good.
Yep.
Don't get lost. Yeah.
Okay, solar events, just as Bruce has said, or sorry, Dave has said, that there's a lot of solar events. It's hard to keep up with everything that that Roger and team are doing. Him and his wife are basically incredible. So we've got these events coming up, we've got Exeter Library that I'll be helping out with that one. Roger does these mostly by himself with his wife. So if you can attend any of these, I think you have a lot of fun. If you don't have a solar scope, it's fun. He has tables of materials. Having somebody who's has an astronomy knowledge and thinking skill set would be very helpful to explain the materials to people. So just think about it. If you can come to any of these are all on our website, so you can look at it. If you have any questions, email me. I'll be glad to answer them.
And we do need the help. I think of the event we had last weekend, I think with the count, it was 105 officially stopped by to look at the sun. But unofficial, I think was more like 115 or 120.
It was a lot of, so this was on the Chester Valley Trail. It was very successful. I was out there barking, grabbing people off their bike, getting them over there. But it worked out really well. Well, I only parked, okay. But there was a lot of people. And so we had your white light scope, and then Roger had his incredible H alpha and spectroscope. Yeah, plus all the materials. And he was focusing materials this time. Was interesting since it's a nature group about animals, and that we think of light spectrum of what we can see is what every animal can see, but that's not true. A lot of species can see into the infrared or into the ultraviolet. Reindeer is a famous one. Sorry, next slide. I don't want to take up the whole.
I think you're done.
Am I done?
That was all
I'll
yours.
just get warmed up.
Not for future.
Thank you. Thanks, Tom.
Just gonna do a quick review of, in July, we had a trip to Cherry Springs. There were 9 of us all together. 7 of us camped in one spot. One other member was a little away from us. Another one was at a hotel. But we had a great time. So, Dave and Ann's tent, Sue and Bob's tent, Pete Kellerman, and our campers over there. So we all sat up around one power pole. And there's the nighttime Dave setting up his scope. So it was a fun event. We had some amazing skies. This is as good as I could get representation of what the night sky looks like up there. The Milky Way goes from one side of the horizon to the other. It was a truly wonderful sky.
Is there really no light pollution? Like
There
you see
is-
light on the horizon,
Hardly any.
It's very minimal.
Yeah.
Milky Way literally went from Scorpio
Yeah.
and the Teapot all the way to Casio.
Yeah.
Wow.
Yeah,
Just
it
one
is.
huge arc.
It is just incredible sky to see. It's worth this 5-hour drive.
Yeah.
So Dave took some pictures with his new electronic eyepiece,
How much time, Dave?
About 2 minutes each. And this is
Andromeda.
unprocessed. I didn't touch
it.
These are what they look like when you look in the eyepiece.
Yeah,
You're
that's
seeing the monitor, and we're seeing the monitor over your head. I mean,
it's even better on them.
say it's even better.
Yeah, yeah.
Astronomy nights.
So
But Dave, if you were looking in the eyepiece, you would think that's what you were seeing, right? Or
That's what you see. That's the colors, that's the
you
detail.
get full color, everything.
Bob said when she first looked through it, the view was trippy. But it really is, and if you actually look through this eyepiece as it's collecting light and gathering it and stacking it on fly, you actually see it get better and better and better, and all of a sudden, boom, color comes in, it's like, whoa.
Yeah.
And that's what it looks like.
can you use a Barlow with that? No.
No, it's, you don't, actually, what you're looking at is a tiny TV screen. It's what you're looking at in the eyepiece. You're not actually looking optically, it's a tiny TV screen, so. So Andromeda, this is and
You know, it should be Swan.
the swan, so this is like this, the swan is upside down, there's the bottom of the swan, there's the head. So that's the Swan Nebula. So those were both with Dave's setup. And I took some shots with my Sea Star M13,
M51.
M51, the Whirlpool, and then the pair in
M81.
M81, M82, the Cigar Galaxy and Bode's Galaxy. There's Dave's the ducks,
That's the wild duck.
the Wild Duck Cluster M11. That's the Eagle Cluster, the Eagle Nebula with my Sea Star.
Did you ever see wild ducks in that cluster?
Oh yeah, all the time.
That's what I figured.
Another globular cluster, the Pac-Man Nebula, which looks better on the TV screens, and Ptolemy's cluster, open cluster on the far right. And of course, we did take a break to go to Lyman Run, which is only about 7 miles. There's Dave coming out of the water, and I think Bart said somewhere swimming in here. But it was Lyman Run is a beautiful, beautiful park.
Who's bucket?
Yeah, that was my bucket.
Okay.
That's like
White bucket.
So that's where you have to go to get showers anyway. So I went for a swim in the lake and then shower, and the water was absolutely phenomenal. It was wonderful. So, and I'll mention York County Start Party is next week. Right now, the weather is looking pretty good. It starts Wednesday, it goes to, and then we leave on Sunday. I plan to go like Friday, Saturday if the weather's good, but it's a great event. It's not as dark as Cherry Springs, but it's a lot darker than anything around here. So,
And it's only an hour away.
it's only an hour away. You can even come down for an evening. You don't have to camp. You just come down for an evening. It's an hour away. All right, so Bruce, I'll bring yours up now.
No, you wouldn't.
Slide this thing. Right, loading meeting control. Here we go. Slideshow. Okay. Next one.
Yeah.
So hi, everyone. As we start our fall season, usually like to give an overview of what our monthly meeting presentation topics and who the speakers are going to be. And in the years that I've been doing this now, try to follow the same concept, namely to try to get topics that vary tremendously from things that could be very astrophysical, cosmological, to planetary science, to robotic exploration, even to some more theoretical types
Well,
of.
they've let in people who.
So,
Couldn't have been
and that's
ready.
certainly the case here. So, some of these may change over time, but I think this is pretty set. And again, as in the past, whenever possible, try to get our club members to be presenting. We also have 4 NASA Solar System ambassadors in the club, so some of us will present, and then get people from academia, from JPL, NASA, Marshall, even the European Space Agency, whoever can, thanks to Zoom, we're not limited to our geography or time zones. So, and that's certainly the case here. So just very briefly, if you look at these talks, I'll introduce our speaker tonight in a moment, but tonight's talk and next month basically have as a focus cosmology and issues surrounding either dark energy and or dark matter. Okay, 2 great speakers. Tonight, Dr. James from Penn, October, Dr. Huff from JPL, who I've heard speak, real expert. I think he's one of the project leaders on the Euclid telescope, so he'll give a good talk. Then in November, I'll talk about chaos. Okay, our lives are all chaos, but chaos theory is a real thing, not just something from Jurassic Park with the Jeff Goldblum character. And I've actually heard Dr. Phillipson give a talk on chaos theory as it applies to astronomy, and it's really enlightening. So I think you'll enjoy that. January, we switch over to a speaker that I wanted to get last year, and because of scheduling issues, we had to kind of rework things. It also was rather fortuitous because this individual's research was kind of developing, and so by giving it more time, we're actually benefiting. So point is, we have Dr. Karahashi Nielsen of Drexel, and I selected her because she's a leader in neutrino astronomy. For those of you that follow the field a bit, over the last couple of years, this has been considered one of the hottest areas in astronomy, and she is an absolute expert and has agreed to come and speak with us. And then in February, we switched to one of our really esteemed speakers, a society member, Solar System Ambassador John Conrad. For those of you that have been around, he has amazing talks on a variety of subjects, and he's going to give a talk on basically cosmic wrecks, collisions near and far in our solar system, and dive into some things that we may not necessarily think about all the time in this subject matter. So it should be very enlightening. Then in March, we're switching over to a speaker from JPL. Now, those of you that have been around for a few years, in the past, I've gotten speakers from JPL who were experts on robotics. We had, I think, 3 of them, okay? This guy, Masahiro Ono, is almost like what you would call a wunderkind. I think he's like 23, and he's just, amazing. And I've heard him speak. He is developing some adaptive autonomous robotic systems that are definitely going to go to Mars, and they're being planned for future trips to Europa and even Enceladus. And a lot of them, these so-called EELs, exobiology extant life surveyor, look like snakes or eels, and they're being tested in Iceland and Greenland and Antarctica. He's going to give a talk. I think it'll be really enlightening. Again, switching gears to a slightly different subject matter. Our April talk will be the best one of the year. Yeah. We have a real expert in our society president, Dave Hockenberry, in astrophotography, and he's going to give us kind of an overview, sort of how the field has developed from being very laborious and really time consuming to now technology is making things much easier, as you just saw from some of those images. And if nothing else, I guarantee you will see amazing astrophotographs. I mean, Dave's stuff is like trippy polished. Then in May, we close out with Dr. Anne Pommier from the Carnegie Institute. She's going to give a talk on Mercury. Again, I've heard her speak. Really excellent dynamic speaker. What have we learned from Mariner, from the Messenger missions? What new missions are planned in the near term to Mercury? It's one of the least understood or least appreciated of all the planets in our solar system, and it's not even as far away as Jupiter and Saturn and Pluto. And then, if there is interest, we can have another special presentation from a former club member who is an astronomy teacher, is a member of ACAAP. Her name is Deborah Stavic. She is, I think, currently still at Friends School, and she has done some amazing work this past summer in Chile. I mean, she basically toured throughout the Chilean Andes and visited a number of astronomical sites and observatories and has a really, really cool presentation. It's not on our schedule per se because we don't meet in the summer, but she can be very entertaining, should be very informative, so we may be able to fit it in. So anyway, that's the overview for the year. Maybe subject to change, but I hope I've tried to capture diversity here, both in subject matter and in speakers. And with that, I will introduce our speaker for tonight. It's a real privilege to have Dr. Bhavnesh Jain come in and talk to us remotely. Dr. Jain is the Walter H. and Leonore C. Annenberg Professor in Natural Sciences in the Department of Physics and Astronomy at University of Pennsylvania, and he's co-director of the Penn Center for Particle Cosmology and co-director of the Penn Data Driven Discovery Initiative. Dr. Jain did his undergraduate work in physics at Princeton, his PhD in physics from MIT, and during the time that he spent at Penn, he's worked in a number of areas, basically in cosmology, studying dark energy, gravitational lensing, and machine learning concepts in astronomy. And tonight, he's going to be talking about dark energy, which many of us may know something about, this rather elusive energy that seems to be implicated in the acceleration and the expansion of the universe, and we don't fully understand it. And until very recently, we thought it was a constant. And Dr. Jain's going to shed light, but that is not the case anymore, based on what we now know. And so some of the questions that he'll answer are, the nature of dark matter and dark energy, how these forces in our universe shaped the formation of galaxies and galaxy clusters as we see them today, and just how we went from very small scale structure in the universe to the structures that we have present day universe. So should be a really enlightening talk. So Dr. Jain, thank you so much for joining us. We really appreciate it.
Thank you, Don. It's
That was
great.
Bruce. That was Bruce.
Can you hear me okay?
Yes,
Yep.
yes, good.
Great. Let me first check on just logistics. I may have misunderstood. I thought I would be starting at 7:30. Now I see it's approaching 8 o'clock. When will we wrap up?
When you're finished.
Whenever you finish, take what time you need.
I mean, I had planned to finish at 8:20 and have time for questions until 8:30.
You can go
So
longer than that, that's fine.
I'll try to finish by 8:30 anyway, and then we can do some questions. So thank you again for having me. We can keep it as interactive and casual as you like. My own research has got a pretty significant AI component, and I'm just coming off an afternoon lecture introducing AI to students who have no background in math or coding. So just to give you a heads up that that's like a significant additional interest of mine. And so if you're curious about how AI is impacting astronomy or science in general, or what Penn is doing about AI, that's also something we could talk about. But I'll stick to the topic and get started. Right, so I'm going to tell you about what just happened to dark energy, and just extends to the last year and a half, which is a microsecond in cosmological time. So to get up to there, We'll first talk about gravitational lensing and how we map dark matter. I'll introduce three cosmic puzzles, which are keeping a lot of us up at night. And then I will talk about this one singular result that dark energy seems to be evolving in time. And then I'll give you a glimpse about my own work on AI and cosmology. So can everybody see the slides okay? I guess I could make them a little bigger.
Yeah.
Great. Or should I just like share screen? How's that?
Better.
Okay, great. So you have probably heard that we began with something that was mistakenly called a Big Bang. And the present time is a bit over 14 billion years. We don't know much about what was before the Big Bang, but there's plenty of theoretical speculation. We do know that when the universe was 380,000 years old, it went from a glowing hot plasma to neutral hydrogen and helium. And that, let's just call it a billion, when it was a billion years ago, it had formed a lot of galaxies by then. And from 1 to 14 billion years, these galaxies have been growing and evolving in time. So I'm going to jump to the idea of gravitational lensing. So this is a cartoon picture on the left, where every little green blob is a galaxy. And if between that picture and you, there was a giant black hole or a galaxy cluster, what you would actually see is the picture on the right, where the shapes of galaxies have been stretched almost beyond recognition in the close to the black hole or cluster, and further away, their shapes are changed much more subtly. Does that make sense? So the further you are away from the big lens, in this case, a galaxy cluster, the weaker the distortion. The reason we have the distortion at all is because in Einstein's gravity, space itself is curved, and so light rays get bent just like they do going through a magnifying glass. So in fact, nothing we see in the sky is the true picture. Everything has been, twisted or expanded a little bit because of light bending between the galaxy, a star we see, and our telescope. So I'll show you a couple of beautiful pictures of when lensing is really strong. But my own interest is in the typical line of sight. So the typical galaxy on the sky has been stretched by about 1%. And if we can measure that, then we can use the stretching of the images of galaxies to make a map of dark matter. So that's the idea in a nutshell. It's like if you're looking through the water in a swimming pool, and if the floor of the pool has some pattern, then just by looking at how the pattern is messed up, you can figure out something about the water, right? And similarly, we are learning about dark matter by looking at how the shapes of galaxies are changed. So this is the dramatic version of lensing, where this galaxy cluster and the elliptical galaxies in it are bending the light of this distant blue galaxy behind it. And so the galaxy would have been a little smudge, but it's been stretched into this beautiful arc. So this was the thing that Einstein had already realized could happen. But then he said, what are the chances? Not in a million years will we see something like this. Well, it took 50 years, but in the late 70s, it was detected. And now Hubble measures a lot of these routinely and web. So that's the beautiful but very rare version of gravitational lensing. I work on the very unspectacular but very common version, which I'm not even showing because you can't see it by eye. But I'm showing you something pretty amazing, which is the largest map of dark matter that we made a few years ago with a Penn postdoc, Marco Gotti, and a grad student in England, Niall Jeffrey. And this is a map of on truly cosmic scale. So you can see 100 million light years. So, you know, the size of our Milky Way is like 50,000 light years. Our nearest galaxy is order a million light years away, Andromeda. And when you talk 100 million light years, those are cosmic scales. What I mean by that is that these hot and cold spots that you see are kind of a typical sample of the universe. So what are these? The red is the big galaxy clusters. So if you look at, can you see my cursor?
Yes.
Okay, so if you look at this big red blob in the middle, that's like a really gigantic galaxy cluster. And the dark blue regions are the cosmic voids. And these elongated filaments are collections of clusters. And these are the largest superclusters that we've ever found. So this is a map on cosmic scales. The particular shape of the map has got to do with practical considerations. It's a part of the sky that's visible from Chile. So there's a mountaintop in Chile where this telescope that we used for 6 years is located. And this map used the images of 100 million galaxies. We're about to release a final map, which uses more than 200 million galaxies, but it's over the same footprint. Any questions?
Dr. Jane, how do you know when a galaxy you say has 1 or 2% of its being, light has been bent? What reference are you using for that? What characteristics of the galaxy are you using to determine it's bent at all?
Great question. You just saw a picture of a galaxy. They have pretty interesting shapes. They're already elongated or have spiral arms. And so for an individual galaxy, we have no idea actually. That's why the 100 million is super important. The thing about lensing is that it produces like a coherent distortion. Like, suppose you have some wallpaper and you look at it through a magnifying glass, then the magnifying glass will like stretch all parts of the wallpaper. And similarly, gravity being a long range force, it very roughly speaking is going to produce a coherent stretching of a million galaxies. So we kind of study like a million at a time together. And then we can be sure that, okay, in that part, it's a elongation and a dilution of the galaxy by 2%. In that part, the galaxy is actually shrinking because there's a cosmic void on the way that is doing the opposite of a magnifying glass. So we do it statistically. Does that make sense?
Yes, thank you.
Right. So this is called the large scale structure of the universe. And, theories predict what it should look like. And we compare a theory to a map like this. There's no direct way to do it because this particular cosmic void or this particular supercluster have no special significance. We have to quantify the nature of this pattern. So that's the part that's a little abstract. But I'm zooming in here quite a lot to a small patch of the dark matter to show you that where we think there's a big cluster, in fact, there is a huge concentration of galaxies. So, as you may know, dark matter and galaxies, they do this dance together because of gravity. So galaxies are attracted to the dark matter, and that's where they tend to cluster. And if you look at a void region, you will see a pretty empty part of the sky. So that's kind of a reality check. And that's also how we relate the formation of galaxies to the presence or absence of dark matter. That was a really quick overview of how we do gravitational lensing. Now I'm going to step back. To do cosmology, we use not just lensing, but we use other methods. We use what's called the cosmic microwave background. We use the three-dimensional distribution of galaxies. So we use many different measurements. And of course, we use supernovae. So supernovae are the way that dark energy was discovered in the late 90s, and they remain one of the best ways of studying dark energy. So putting all these ways of studying the universe together, supernovae, lensing, galaxies, and the distant cosmic background, we have arrived at some puzzles. Why do I call them puzzles? Around the year 2000, we arrived at what we call the standard model of cosmology. We said, well, the universe definitely has photons, it definitely has electrons and protons, but it also seems to have dark matter and dark energy. Two mysterious things that I'm sure you've heard a little about, and I'm not going to give an introduction to them, but the one sentence description of dark matter is that it's a type of particle or a black hole or something else that doesn't interact with light directly, so we can't see it directly. Dark energy is some form of energy that fills all of space. And the only reason we think it's there is that the universe's expansion is speeding up. Whereas anything reasonable, like matter or even dark matter or even radiation, would make the universe slow down because of their gravity. So dark energy has a repulsive gravity. So the standard model was that dark matter is of a certain type called cold dark matter. Dark energy is the energy of pure vacuum called the cosmological constant. And this model emerged around the year 2000 and for 20 some years fit all the data. So it's, even though it's very mysterious, it's mathematically very simple and seemed to work. Then these puzzles showed up. The first puzzle is called the H naught tension. H naught is the rate of expansion of the universe, and the universe seems to be expanding faster than you'd expect. Very briefly, the structure formation tension, called the S8 tension, is that galaxies and all those big filaments, they seem to have grown slower than expected. So what do I mean by that? Now I'm showing you two really important data sets. On the left is a picture of the baby universe when it was 400,000 years old. And the hot and cold spots are a picture of that plasma. So the red spots are where the plasma was hotter, the blue spots are where it was colder, and these are tiny ripples in this plasma. As the universe expanded, the parts that had more stuff formed galaxies, the parts that had less stuff formed cosmic voids, So the fate of the universe was set at that time. On the right is the universe that we measure around us, and it shows similar blobs where more stuff, less stuff. The color schemes are different. Everything about the two maps is different. But the pattern and the idea that there's regions of more stuff and less stuff is the same. And we care a lot about this because it's tied to the origin of the universe. What produced these little irregularities has to do with quantum fluctuations at the origin of the universe. So I'll just stop there to motivate why we care so much about this seemingly random pattern. Any questions? All right. So the lumpiness of the universe on the right is a little bit less than predicted, by which I mean, now I'm showing this with a simulation, that if the theory is right, the simplest theory, we should see a pattern that looks like this, but what we see is the one that looks like this. And you can see the contrast is a little bit weaker. That's what I mean by structure has grown more slowly. All right. The topic of my talk is the third cosmic puzzle. There's a lot of terminology on this slide because the story is a little complicated. So BAO is a particular feature in the distribution of galaxies that I'll show you in a second. Combining observations of BO and supernovae and the cosmic microwave background and weak lensing leads to the conclusion that dark energy is changing in time. And this is a very startling conclusion. And the particular way it's changing is called the phantom crossing, which I'll explain in a second. I won't explain any of this, but this is an actual measurement of that early plasma. And the bumps and wiggles, they are caused by the oscillations of the plasma, the sound waves of the early universe. Jumping to the universe around now, those oscillations leave an imprint in the distribution of galaxies. So there's more galaxies where you see the bright rings and fewer galaxies elsewhere. The pattern is not visible by eye. This is not real data. This is like a synthetic data to show what it would look like if it were much stronger. In fact, we have to make measurements again of 10 million odd galaxies, and then we measure this thing in the upper panel. And you can think of it as the number of galaxies as you go from the center of one of these rings, as you go away from the center, if you count galaxies, then when you reach the bright part of the ring, there are more galaxies. And in fact, the bumps that you see in these measurements correspond to that excess. If you look at the numbers, it's like a 10 or 20% excess. The remarkable thing about this plot is that there are 1, 2, 3, 4, 5, 6, 7 different measurements at different distances from us where we see the same excess. So if you convert distance to time, because light takes long to get to us, the further we look. So the measurement is spanning, we are here at 0, present time. So it's going from 4 billion years to 10 billion years to 11 billion years. So from 4 to 11 billion years away from us, we measure this pattern called the baryonic acoustic oscillations. And this measurement lets us figure out how fast the universe is expanding. And I wanted to show you the plot below because it's the key plot that shows that dark energy is evolving. So I'll say a few things about it and then I'll ask you if you have questions. So the dashed line is the standard model of cosmology's prediction. That says that dark energy is constant in time. That's vacuum energy. That's the simplest thing. The points, the blue points, are the measurements from data. They don't fall along that dashed line. The error bars are these gray kind of violin plot, it's called. You can see they're pretty big. That's why the measurement is really fresh and still debated. So, but if you look at the peak, the central value of the point in blue, you see that it's above the dashed line at the earliest time, closest to us, and it falls below the dashed line as we go to earlier times. So what's the thing I'm plotting actually, or that I'm showing here? This is a little harder to explain. It's related to the pressure and density of dark energy. So it's called the equation of state of dark energy. And for pure vacuum energy, they are equal and opposite in sign. That's why dark energy is repulsive. But the fact that it's below -1 is something we did not expect at all. The, simplest interpretation of that would lead to a universe that is completely unstable. And we know ours is not unstable. So this result tells us that we have to think about dark energy completely differently if it holds up. Right now, it's looking pretty solid, very hotly debated. Many people are checking the measurements. You will hear every 6 months, you'll see new headlines about it. Yes, dark energy is evolving, or this measurement casts doubt on the evolving dark energy story. It's the hottest thing in cosmology. Any questions?
Yes, I have a question. I'm sitting here listening to you trying to formulate this question properly in my head. As the universe expands, isn't it expected that the energy would evolve to either fill the space or create more energy to fill the space?
Great question. Vacuum energy, which is a really crazy idea, but I should emphasize it's more than a century old. Ever since quantum mechanics showed up, people realized that the vacuum doesn't have to have zero energy. And in the 60s, people realized that if it doesn't, it will have an impact on the cosmos. And its behavior is like the math is really easy, and the physical intuition is almost impossible. The math tells you that pure vacuum energy, the density stays constant in time. So if you imagine a balloon expanding, if it has particles in it, then it's the same number of particles, right? So as a balloon expands, the gas density falls. because it's the same mass divided by bigger volume. Dark energy doesn't do that. The density stays the same, so the total amount of it grows.
Right, that, yeah, so it's good.
So that's the answer. I gave you a little roundabout answer, but to circle back to this question, the simplest form of dark energy, vacuum energy, dashed line, that corresponds to constant energy density. And the measurements we are seeing, it's changing. Just so you see it, this is the money plot that cosmologists are debating, where this crossing point of the two dashed lines is pure vacuum energy, and the green contours show you what is allowed by the data. And you can see that vacuum energy is not allowed by the data. And we quote a statistical significance, and that significance is like 1 part in 10,000 or something. The odds that this standard model is correct are really low. That's the straightforward interpretation of the data. All right, I'm not going to debate further what the weaknesses or loopholes in the data are. Suppose we take it seriously. That means the standard model of cosmology has to be abandoned in one key aspect. It also means the future of the universe is up for grabs, and I'll explain why that is in a second. The key takeaway is that it means that not only is dark energy evolving in time, but it's actually something more complicated. We might have to come up with an integrated picture of dark energy and dark matter that are talking to each other. And that's the only way to explain what's called phantom crossing and retain some simple principles of physics like energy conservation and stuff. So if that's the case, if dark energy and matter are interacting and they are able to trade, like matter is, some small fraction of matter is decaying into dark energy every giga year, then it means that we really don't know what's going to happen in the future. Will this interaction go this way or that way? Will it slow down? And so just when we were coming to grips with this existentially bleak scenario of a vacuum energy driven accelerating universe where every galaxy is going to disappear from the sky, this result says maybe is a big crunch after all. Maybe the expansion will slow down and halt and recollapse. That possibility is now back on the table. We just don't know. So confusing, exhilarating.
Is there any data that suggests that matter in the universe is actually changing as far as like the total matter? Could it be morphing into dark energy or vice versa?
That's a good question. There's no direct evidence of it. This is just, so now we are in the realm of which theory provides a more plausible explanation of this surprising result. And this theory, there are theories in which dark matter decays into dark energy, provide one of the less crazy explanations of this data. In parallel, the pursuit of what the hell dark matter is of course going on, and there are many direct experiments trying to nail it down, but so far, nothing compelling. So I can stop there. I'll give you like a one slide picture of the AI approach to cosmology. So this is that same dark matter map, just a different color scheme. And the main goal of cosmology is you have a model of the early universe, you have a model of dark matter and dark energy, and you try to figure out which model reproduces a map like this the best, right? And we do it using lots of calculations and simulations and rigorous statistical methods. Now, along comes AI, and AI says, you give me a picture of a cat, I know how to tell you what type of cat it is. I know how to tell you if you have a picture of a crime scene, whose face that is. I can, and so the AI claim is that you have a bunch of theories, give me those pictures and I'll tell you which one matches this one. So that's one theoretical prediction. That's another. This one doesn't look like the real universe. Agreed? But the first one, it's hard to tell. This one, it's hard to tell. The point is that it's not a particular, blob that's supposed to match. You're supposed to ask which pattern looks like the real one. And so AI is pretty good at this exercise. So we are at the same time that we are using our tried and tested methods, we are also applying AI, and we are confronting the same problem that all AI, ChatGPT and every other AI, has to confront. How does it work? Why is it saying this? Very hard to tell. And so there's this tussle in cosmology that, I'm part of the AI proponents who say that this is really powerful. We should try it, see how far we can push it. And there's others who say, I'm going to be dead before I trust a result coming out of AI. So it's a pretty lively time. If you go to a conference, you can, see some heated debates. And yeah, let me stop there, and happy to discuss further.
What do you use to train your AI?
Great question. We have, a 40, 50-year history of doing massive computer simulations. So we have simulated universes in which there's like currently a trillion particles. Each particle is like a little galaxy that we set going when the universe was very young. And then they evolve, they interact with each other, they form galaxies and all that. So those simulations are what we use to train the AI. And, that raises some questions like, what if the real universe isn't like any of your simulations? In that case, AI is not good.
Dr. Jane, you may have mentioned it, but could you define what you were referring to before as a phantom crossing? Just curious.
I did not define it. Phantom crossing is when, vacuum energy has this equation of state of -1, which is that the pressure is exactly the negative of the energy density. The repulsive pressure is equal to the energy density, opposite in sign. Phantom crossing refers to the fact that dark energy had even more negative pressure in the past, and it's weaker in the present. So it crossed that vacuum energy. And no simple theory can produce a phantom crossing. That's why this result says we have to think about it in a more complicated way.
Dr. Jane, the question has to do with how the data that you're showing us correlates to the observations that we now have from both Hubble and from Webb, who've looked at the data from the cosmic microwave background map and the data points that we managed to get
relatively well from the nuclear group and others that think that in the early part of the universe, gravity kind of kept the expansion of the universe to a certain point. And then about 4 billion years ago, the expansion really took off and accelerated. Where does your data kind of fit in with these observations, which seem to me, at least at this point, are pretty good?
So the statement you made correctly that the universe is accelerating in the last many billion years is absolutely correct. And no data set disputes that. The evolving dark energy story is a wrinkle on top of that. It's like how that acceleration itself changed. And to arrive at that result requires combining all those different data sets, the supernovae and the galaxy surveys and the lensing. And that's one of the most worrying things about this result, that it requires assembling all these different data sets. And so we better be sure that we understand each one of them well enough that when we put it together, we trust the story. You know, this phrase, extraordinary claims require extraordinary evidence. So this claim is a year and a half old, and it's been scrutinized heavily. It's holding up, but it's still very early in the story.
Dr. Jane, you mentioned a few moments ago in the context of the Phantom Crossing that been a weakening of, there appears to have been a weakening of dark energy. Is that what would potentially fuel, if you want to call it that, a crunch?
Right. Great
That-
question. So we have seen a weakening over the last several billion years. Because we don't have a theory, we can't predict whether it'll keep weakening and just like die out.
Mhm.
But if it does, then the expansion will kind of slow. But something even more dramatic could happen. It could convert to heavy matter. And that's what it would take to lead to a crunch.
So more gravity.
Yeah, we need more of the
Hmm.
the type of gravity that, brings a baseball back to the ground, namely attractive, not repulsive.
Thank you.
Sure thing.
I'm kind of wondering if I can ask a quick question here. The theoreticians, considering that these new theories of dark energy are being considered independent or separate from, quantum field vacuum energy, if they're looking at these new theories, what I'm curious what form these theories might take. Are they going to be like a field theory, like EM theory? Are they going to be a geometric theory, like general relativity? They're going to be more like string theory or otherwise?
Yes, which is to say, people are thinking about all of the above. So that's a great question. So quantum field theories allow you to couple dark energy to dark matter. So that's one type of theory that we are actually playing with at Penn with my theory colleagues. A completely other alternative is that dark energy actually is vacuum energy. It's gravity that's not Einstein's gravity. And there's a fifth dimension that is, instead of 3+1, there's 4+1 dimensions, and there's a subtle influence of that extra dimension. So all these scenarios are being explored, but nobody has come close to writing out a theory that looks, appealing.
Another question I had was, at the cosmological scale, if there has been any observation of gravitational and versus dark energy interactions. That was the question I wrote down at the beginning, and I was wondering about that. But it seems to me that you're using gravitational lensing to understand dark energies. But are they necessary? Aside from the observations that you've made, theoretically, is there a dependence, or has there ever been observed like an interaction, and if that can be characterized?
There is no such interaction that the data show a strong evidence for. That's why for all these years, Einstein was right. Yet again, this kind of result comes up. But these possibilities are also on the table.
Thank you.
You all have great questions. Enjoyed the discussion. This evolving dark energy is so startling that I really wanted to talk about it, even though it's a very abstract kind of result, even for us.
Dr. Jane, I know it's early days, in understanding this. Do you have, at this point in time, a preferred alternative theory or theories, or are you not even willing to go there because it's too speculative?
Just because I worked on alternatives to Einstein's gravity, I worked on how we might test them. And I collaborated with my theory colleague who had such theories. So I'm pretty excited about that possibility. But conceptually, to me, the most natural explanation is the one I referred to, that dark energy and matter have some interaction which lets them energy flow from one to the other.
Thank you. Any other questions? Thank you.
Thank you very much. It's a pleasure to meet you, even if virtually.
Good luck with your work.
Thank you.
Great job. Thank you.
Thank you.
Thank you very much.
Very much.
Okay, now my mind is slightly bent into a pretzel.
Yeah. Should be your best of my brain hurts.
Is it having a phantom crossing?
Having a fan of something or
true.
another. In any event, now we all have something to sort of think about and puzzle over the next month, and I guess we're gonna hear from the dark matter side next month.
And sure, we thought that
And dark energy as well, so maybe we'll get a completely different perspective next month when we come back to this.
Probably.
So hang on to your hats, the ride is just beginning. Anyway, thanks everybody for coming, and be sure and show up next month while we continue this very perplexing subject. Really great job. And quick thank you to everybody who's bringing in all these delicious caloric cookies.
Is that okay? Is that the right size?
Yeah.
Okay, good. Thank you.
Doesn't really span.
That's okay. Especially if you're just. Yeah.